students connect the dots between classes and real life, speakers will be asked what they do every day and how they apply their knowledge of STEM in their everyday life. This will introduce students to different industries and motivate them to nurture their problem-solving skills and not give up. The most common question I get asked in my math class is, why are we learning this, or when will we ever use this math concept? This program is aimed to answer these questions and encourage students to learn more and do more. With that being said, I'd also like to introduce one more person who makes this all possible. I'm pleased to welcome Madhangi Shivaramakrishnan as the Program Director for Triangular Talks. Madhangi is a strategy and operations leader in the pharma industry with about 15 years of experience. Madhangi has always been interested in life sciences and healthcare and studied biology, engineering, biomedical engineering, and eventually pursued an MBA. She currently works at Gilead Sciences in commercial operations, where she leads a team that helps shape business decisions through data and analytics. Now I'd like to give the floor to her. Oh, I think you're muted. Can't hear you.
Can you hear me now?
Yep.
Okay, sorry about that. Thank you so much, Rhea, for that introduction. I'm thrilled to be part of Triangular Talks, working with the broader board of directors at the Agora Math Circle. I'm looking forward to working with all of you to continue to shape this program as we move forward. So please continue to provide your feedback, both what is going well as well as what could be different, so that we can shape this together. With that, I'd like to introduce the speaker for today. First, let me start with the topic. The topic is how cloud is driving innovation in gaming. And the speaker is Mr. Uthappa Kattera Chengappa. We're thrilled to have him here. Uthappa is an experienced software professional with 19 years of success in IT infrastructure, cloud design, and application architecture. He is a distinguished digital transformation specialist who advises industry leaders to establish public cloud strategy. Currently, Uthappa is working with leading gaming and media enterprises building robust cloud-based design for next-generation gaming and media distribution. He has a bachelor's degree in electronics engineering and is a certified professional on enterprise architecture. Without any further ado, I will turn it over to Mr. Uthappa. He is comfortable with you chiming in with questions along the way, so feel free to unmute yourself with any questions. You could also, put your questions in chat, which I'll continue to monitor. Over to you, Mr. Uthappa. Thank you for being here.
Thank you, Madhangi. Hi, everyone. Are you able to see me in video as well as I'm able to share my screen?
Yes.
Okay. First of all, thank you so much for inviting me part of this Triangular Talks. I'm so excited to talk to you all. I believe it's a great opportunity to meet the young minds here and also learn from you all on what you think and how you look at the world going forward, right? Because you are the next generation who are going to shape this earth and the lives around us. So I really feel fortunate talking to you, and I deeply and sincerely thanks the organizers for arranging this. Okay. All right. So thanks, Madhangi, for that quick introduction. So again, at a very high level, software development as such and engineering has multiple facets. Right. So one facet is essentially coding. You write a code, you write an app, you build an app. The second is the operations of it, right? How do you manage it? How do you update it? How do you keep it going, right? Somewhere in the middle is about the designing of how to get from A to C, right? From development to operations, right? So I play a role somewhere in between there in terms of building that what we call as infrastructure to host these applications that the developers build, and then making it available for a massive scale. When I'm taking massive scale, 1 million users, 10 million users, lots of network, lots of servers, lot of traffic that's coming in, right? How do you make sure that the application doesn't fail? Take an example of, say, Netflix, right? How do they scale when they release a new movie or a TV series so that 1 million people are watching at the same time? How does things work in the background, right? Very similarly, we do things for gaming industry. So when a game developer releases a game and it's massively available for players around the globe, how do you make sure that the infrastructure that's needed to support is available, right? And what challenges that come with it, and how do you solve those problems, right? So those would be some key core topics that I'll be covering today, and that's something that I do for some of the leading game developers, media distributors in the West, US region for some of our large customers. Okay. So here is the agenda. Again, confirming that you're able to see my slides and I'm in the agenda slide.
Yes.
Okay.
Yes.
All right. Thank you. So so we'll introduce what is gaming, specifically digital online gaming, and then we'll talk about how the infrastructure aspects of gaming works, right? When you play a game on Xbox or PlayStation or Nintendo or even mobile phone, what happens in the background, how that all comes together. And then we'll talk about some of the challenges the industry is facing today, in terms of, how do you make this game sooner, faster, and work for everybody, right? And then we'll introduce cloud. Most of you might have heard this word. Some of you might have even tried, cloud for some of the things that you do. In fact, you might be using cloud. In fact, Zoom right now is hosted on cloud, right? So we use tools and utilities today that are hosted on cloud, but we'll go a little more deeper into how it is built, and then finally, bringing those together, the challenges that the gaming developers and organizations face, and then how does cloud help with some of those, right? And then finally, what's next, right? How do you see the gaming environment, 2 years from now, 5 years from now, and 10 years from now? How things are changing? I'll probably talk about some of the innovations that we are seeing. Hopefully, I guess the idea is here to get you excited, and also make sense of what you're learning today. Everything in here includes physics and mathematics. All the aspects that you're learning today, we'll try to demonstrate some of them as well, and then you'll see that how they are applicable in day-to-day life, as well as solving problems such as the ones that are faced by the gaming industries. Okay. So what is gaming, right? Gaming is pretty simple. You hold a mobile phone or Xbox controller or PlayStation, Nintendo, and you play a game, right? It's called as a digital online game. Why it is online? Meaning to say you are on the internet and you are essentially using a controller in your hand, and then you play with your friends and families, right? And that's called as the multiplayer online game. Why it is such a big deal? Look at the numbers. There are 3.2 billion players today, or will be in 2023. Right now, it's around 2.785 billion, right? It's massive, right? Whenever a game is released, for example, there was a game called as Apex Legend. When it was released, within the first 30 days, there were 100 million players, okay? And if you look at the overall market, it's around 314 billion by 2026. As I was saying, it's played with mobile phone, on your PC and controllers, and there are some key players who actually develop and distribute this game for you, right? So getting in some more growth of it because of pandemic, we couldn't meet our friends, families, so online gaming really picked up because people were comfortable sitting in their couch and playing, and interacting with folks around the world while doing their favorite thing, which is playing online. Yeah. And then if you see the revenue is also growing, it's expected to grow a lot. And this is an industry that has done well, even pre-pandemic as well as post-pandemic. So online gaming has sustained it's one of the least impacted industries, in terms of overall business value. Okay, and everybody plays games. Men, women, of different age groups, and you'll also see that it's played all across the globe, and there are so many ways you play the games, and it doesn't need you to be on the same game to play with your friends on the same type of device, right? So it's multi-device compatibility as well, right? So again, I talked about there are so many different types of games. We'll talk about multiplayer online games, right? That means you are playing games with somebody across the continent, with your friend or otherwise, online. So it's real time, right? If you look at it, when you're watching Netflix or Disney Plus, it's one way. The content, the video is sent to you on your device. You are not really doing anything. In a gaming world, it's actually two-way. You are actually pressing some buttons and then you're getting the feedback, right? So now multiply that by 1 million users. How do you build that backbone servers or infrastructure to support that large number of volume and the content that is generated by those million players, right? So we'll get into some of them. So while I'll take a pause. And any questions so far? Okay. All right. So how does this work, right? When you holding that PlayStation at home, you essentially connect over internet, right? So that's what the blue cloud is shown here, that you need a fast internet. And then you connect to what we call it as game server fleet. It's essentially large computers with lots of what we call it as processing unit, and then memory and storage. Okay, and these are servers essentially procured by large server providers, and they keep it in a particular data center. And these data centers are essentially large warehouses. Think about it like a big Costco, where they have servers and servers where you connect to them. And then when you play a particular game, let's say a particular part of the game, then you're all getting connected to the same server. So for example, if you're playing Fortnite, it will send you to queue and it will say the queue is full. Why? Because let's say a server can manage 100 users or 100 game players, right? And if you are 101st person, then they'll have to allocate a different server for you, and they'll have to wait for some more players to come and join you, right? So essentially, at a high level, it's you, a player, and connect to servers, and then that server essentially makes sure that multiple players are able to play the same game, and they are in that same world where you are shooting at somebody, they're able to see it, and they're shooting at somebody, for example, or they're clicking a button, or they're creating something using Minecraft, and you're able to see it, right? That's because you're connected to the same set of server. Okay. Now, as an example, right, I talked about why it is so big, right? Minecraft, you might have heard Minecraft, 480 million players play this game, and 120 million active players, right? Fortnite, it actually set a record. Around 8.3 million concurrent users played at the same time. So how do you design such a massive environment for for players to play, right? So let's whiteboard, right? Do this. Okay. So now I talked about you're sitting at home holding a controller or a mobile device, right? And then you need a console, which is an Xbox or PlayStation or Nintendo, right? And then you need internet, and then you need servers, right? It's pretty straightforward, is it? Because now when you connect to a server, you'll have to tell who you are, right? So what are the requirements? Then you have to identify yourself. So user identity, right? You need to know who you are, right? And the server has to know that who you are, right? User identity. Then when you play a game, you have to select a list of games. So there's a list of games that you have to select from. And so somewhere I have to manage it. Then I'd also have to manage user management, right? Let's say profile, right? Your first name, last name, your email address, your sign-in information, and everything. Then I have to manage my game data, right? For example, you see those large trees and cities that are built within the game. How do I store and manage those games, right? Those are part, what we call it as content or game artifact or simply game data, right? And then finally, there is session data, right? What is session data? When you play a game, let's say you pause the game and then you come and pick it up at a later point of time, then that session has to be stored somewhere, right? So that when you come back, you don't want to start from level 0, you want to start from level 5, right? Where you stopped last night. So that's held in what we call it as a session database, right? So as we can see, there are so many aspects that are involved in here, right? So when you look at building a game, because there are so many aspects that are involved, so this is how it actually looks like. Yeah, there is a game session. Obviously, you connect to a game server, but then there is a centralized system which actually distributes the load. It looks at, okay, you are from Los Angeles, you are from London, you are from Hong Kong. Okay, let me place it to the nearest server that you are in, right? So there is a load distribution component which essentially manages that load, and it uses algorithms such as round robin that you probably are working on, and then it'll shortest path algorithms. It'll use ways to know that, okay, do we even have servers in these specific cities where I can distribute the load to, right? So what we call it as health checks, right? And then there's an aspect of matchmaking. Essentially, I need to know the same set of players who want to play the same game, right? So this component will make sure that you are connected to the same server so that you can play the game. I talked about user authentication. You'll have to log in. You'll have to provide your email address and sign in with your password, right? So there's a system that manages it. And you can also manage your friends, right? You can create your own friends group, and then you can chat with them, and then you can play games with them. So there is a database that manages it. And then finally, analytics, right? Everything that you do, even within a game session, excuse me, is captured and it's analyzed for improvements, for them to know the user behavior, to them that you're not cheating, and then you're not found a bug, and then you are gaming the game, to say, right? Now, how do you make it more safer, for young kids? So you essentially monitor it, right? So that kids are not bullied online, right? They're not sending offending chats, for example. So all these aspects are involved in the overall architecture of distributing a game, right? So hopefully by now you have realized, when you hold an Xbox controller, of this session, then you think about all the aspects that happens in the background to make that session of Fortnite or Minecraft available for you. Yeah. Any questions so far? Is my voice coming through well, and then screen is being displayed well?
Yes.
All right. Okay. Let's say now you are excited. You are a game developer, and you want to you have built a game, and you want to make that game available for 1 million players. Okay. Let's go through the process of how do you build that backbone infrastructure to support what we saw here, right? How do I distribute the load? How do I do build the game servers? How many do I need? Where do I place them? How do I manage my users? How do I manage the friends, right? And not for 1 or 2 or 5 or handful, 1 million players, right? How do I do that? Okay. So let's look at what are the different things that we have to talk about, right? One is I need to support 1 million players, right? Meaning to say at any given point of time, there may be 1 million players that could be playing that game, right? Then my players could be anywhere. They could be in the US, Europe, South America, Asia, anywhere, right? How do I manage that the experience is pretty similar to everybody, right? And I want to make also sure that, you know, I'm developing a game and this is a business revenue stream for me, right? How do I make money? And so that, how do I make sure that my costs are low, right? I get maximum out of the money that I'm putting in to make this game successful, right? So let's look at one aspect, right? Of, okay, you have 1 million players. How do I design? How many servers do I need? And this gets into inside of mathematics. Let me show you how. Okay. So here is an Excel workbook that I'm showing. So you know, I talked about you are a game developer and you want to cater to 1 million players, and you see a key term here. It's peak concurrent player, right? Meaning to say that at any given point of time, there could be 1 million players playing that game. You know, as a new Netflix show is released or a new game is released, the hype around it is maximum in that first weekend or the first month, right? So that means you expect a lot of players to play that game during the initial days, right? So here is what, you know, you have done your analysis and you think, you know, if I'm releasing this game, you know, over a month, here is how my count looks like, right? My concurrent players count look like, right? For example, for the initial days, there will be 1 million players, and then overall, slowly the count goes down. However, when I'm designing my backbone, you know, servers, right, I should plan for 1 million. Though at the end of the month, there are only 50,000 players playing that game, right? You want to have that, you know, set up so that you can cater to the maximum count. So in this aspect of when you're designing things, we use this word called as you design for failure, meaning to say you anticipate something will go wrong. You don't usually design for success criteria, right? You design for failure. You think that things will go down, and things will always go down. There will be bugs, right? How do you mitigate them? How do you diffuse them? And how do you reduce the overall impact? Right. So in this scenario, I need to design for 1 million players. Okay, I've done my analysis. Then I know that if you know the server, right, it has 3 main ingredients or, you know, constituents, right? A server is a central processing unit. It has memory, random access memory, which is measured in gigabytes, and then there is storage. Let's just talk about the processing unit. I know from my testing that number of players per processing unit is 1. That means if my server has 10 processing units or CPUs, I can accommodate 10 players, right? So if I do a simple math here, and again, it's just a multiplication, right? So I have 100 players, right? Then I need 100 vCPUs, right? In this scenario, say, okay. Now, if one server has 8 CPUs, then I need 13 servers. Are you with me? Right? And then again, if my server has 32 CPUs, I need 4 servers, right? Simple mathematics, right? So 100 divided by 8 or 100 divided by 32, right? Obviously, server count cannot be decimals, right? So you need to round up to the next level, right? So similarly, if I do my math, you see here for 1 million players, I need 125,000 servers of 8 processing units. Or if I'm using 32 processing units, I need 31,000 of them. Okay. Now, as I was saying, they're not in one place, right? Your players are all around the globe. You have players from, United States or North America or in Europe. Let's say two scenarios, you have 60% of the players, that is 600,000 of them are coming from US, and then 40 are from Europe, right? So now you essentially have to distribute the number of servers into two different data centers where you could actually accommodate that big of a user volume, right? Again, you don't know, because of the advent of social media, there could be some things that could trigger this 1 million to 10 million, right? Now you have to have more number of servers than what you anticipated. How do you build that, right? So think about, as a game developer, at the same time, learning the mathematics, the principles of, if you really look at it, what we just use here is multiplication, division, percentages. But then you also look at factor, probability, right? And then you have to look at probability as a big deal, right? Because you have to know that what is the probability that I'm going to get 1 million players? What is the probability of me getting 100 million players, right? So you work with those numbers to figure out what you need. And then in a traditional way, you would order the number of servers, right? It would, let's say, it takes around 6 to 8 weeks today to get such a big number of servers delivered to you, right? And now you have to think about placing those servers in different data centers all across the globe, right? Remember, okay, then I need large warehouse. Then I need heating and cooling, because when these servers run, they generate a lot of heat. So that means I have to cool down that environment. I need to make sure that the power supplies are intact, right? The servers don't go down. Otherwise, my players can't play the game, right? At the same time, there are more and more players coming from, say, South America, from Africa, from Australia. Okay, who will have poor performance if I just place the servers in US and Europe, right? So how do I cater to those, right? So now think about the challenges in terms, right? So now if you compound everything, you can categorize the challenges that you are facing to host the 1 million players for your game into these 5 different buckets. One is, my players are coming from every place, every different cities. Yes, majority of my players are coming from North America and Europe, but then there are players are coming from different countries. In fact, China, India, the number of players playing these games have significantly increased. And there are numbers to show that, right? And then at the same time, you want to make sure that my experience is fast. You don't want to click the button and then wait for 10 seconds, right? And then I want to make changes to my games faster. I want to add a new world. I want to add, say, new design, a new environment, a new golf course, or new, for example, a waterfall or a forest in my environment of a game, right? How do I deliver that faster, right? At the same time, you have data of 100 million or 1 million players. Their personal information is shared with you. How do you make sure that data is secured, right? How do you make sure that there's no hacker who comes in and steals the data, right? You don't want to get into lawsuits and big trouble, right? You want to make sure that the sensitive data, if user name and password are stored securely, right? And then finally, obviously, I want to make sure that I keep my costs low. Yeah, at the end of the day, I'm not developing a game just for the sake of entertainment. It's part of it, but then I have a business to run. How do I keep the cost low? Okay. Any questions so far? Are you finding this interesting? Are you finding it too slow, too fast? Any feedback so far? Are you seeing anything in the chat? Matangi?
Nothing on the chat yet, Uthappa, but I will open it up to the audience.
All right. Okay. So now, if you look at the topic, you said that, hey, cloud is helping you to drive innovation in gaming, right? And we talked about certain challenges. Now let's look at, okay, how cloud is helping, right? But then what is cloud, right? As I was saying in the introduction, that there are so many aspects of cloud, right? But primarily, if you can, in a major flavors of cloud, I could say there are three types of cloud: public cloud, private cloud, and hybrid cloud. What is a public cloud? If you're using Gmail, if you're using Google Drive, if you're using OneDrive, if you're using Zoom, they're all hosted in public cloud. Essentially, what it makes it public is these are large amounts of servers built by large organizations, and they are spread across different cities in the globe, where you can rent them by the second and use. And then once you're done with it, you just say, I'm done. So you don't actually have to own the servers. Okay. And the key ingredients of building a data center is number of servers, the amount of network, and the amount of data, the storage, right? So any aspects, either of these three flavors, those three would be pretty common, right? Servers, network, and storage. So when you're designing something, you'll have to think about all the three. We only touched upon number of servers in our Excel, where we thought, okay, we need so many servers to cater to my million players. But then you also have to talk about network. We'll also have to talk about storage. I'll show you how you actually estimate those within cloud in some of the slides. Okay. So public cloud is where it's over the internet. You connect over the internet, and then you pay by the second. Private cloud is something you own. You've built a software on top of it, and then so that you use in a very programmatic way, but you still control it. And that sense called as private, means it belongs to you. Hybrid is kind of in between public and private. I start with private, and then I burst into public, and then I connect to public cloud and then make use of it, right? So a little more details around it, right? So as I was saying, public means it's over the internet. Private is something that you control within a physical location that you own or you manage. And then hybrid is something which comes in between the two, right? At the high level, if I have to quickly whiteboard, you can see it here. Let's say I have a user here who's a player, right? And you have your controller, right? And then let's say you build your own servers, okay? And then you connect to those, okay? And you manage all the aspects of this. So this is essentially private cloud, right? So what you do is you build a software layer to interact with the number of the servers here. So you don't physically connect to those. There is a software layer that enables you to connect to those. So in the parallel, you can actually keep adding servers as the number of players come in, and the software layer takes care of making sure that you are sent to the right server. Okay. Now, when you use the rented servers that are provided by large organizations that all over the internet and connect over internet, then that becomes public cloud, right? Now think of a scenario where I have my servers, which can, let's say, manage 100,000 players, but I'm now anticipating 1 million players, right? So now what I can do is I can connect, use a different color. I can connect my private cloud, okay, into public cloud in a very seamless manner, where for the first 100,000 players will use my own servers. The next 900,000 players will use the public cloud, okay? And here I own it, so I don't actually pay for it when I'm playing, but here I pay for it only when this is running, and this is played by second, right? Let's say I'm using 100 servers here, and then for 1 hour, and then each hour costs me 1 cent. So I'm only paying $100. After that, I'm done, right? I destroy this, and I don't have to care about anything else, right? And I could also have connectivity, private connectivity. I can also have data storage, databases, and all built in, so that I can manage those in a very transparent manner. Sorry, was there a question?
If you want this to function, you need to like, you don't want to waste your money on this if the server's still running and no one's going on.
Yeah, that's right. That's right. So nowadays, the people or game developers, they don't want to even own them, right? They want to connect to cloud, rent them as you need it. And then once you're done, come out of it, right? So as a game developer or a game provider, I'm at a very low risk, right? I don't even have to know my game will be successful or not, because I don't have to buy these physical hardware and store it somewhere. What if my game doesn't work, right? What if people didn't enjoy my game, right? Now, with the power of cloud, you are essentially renting it, and then once you're done with it, similar to the the power charges that you pay for the utility company, right? You don't own the physical lines, you don't own those large transformers, but you just pay for the number of units of electricity that you use, right? It's low risk for me, and I'm okay to pay that usage charges instead of owning the backbone infrastructure. Very similar. It's an correlation between a utility company and public cloud. Okay. So what are the other benefits of cloud, right? Again, we touched upon you don't have to manage hardware. You don't have to buy. It's offered as a service, as a telephone or electricity service, right? And you pay per use model, right? If you don't like it, cancel it, right? So similar to Netflix subscription. Global availability. Look at the cities where, this is an example of how Microsoft Cloud in different parts of the globe, right? So you have data centers in 66 cities covering 140 countries, right? So I can just go into a management console, which I'll show you right now, and I can go and start servers in any of these data centers. Once I'm done with it, shut it down, and I'm done, right? If I want, in fact, look at it right now. It's US, it's daytime, so I can move my applications closer to the users based on the time zone. So I can have game running in the US right now. You expect North Americans to play the game more than probably back in India, right, where it is almost midnight or more. And then as the day progresses, I can reduce my server count in North America and increase the server count in India or in Asia Pac. Yeah, so I have that flexibility. Obviously, you'll have to make sure that there is some automation or to spin it up and spin it down. But knowing that you have that option is awesome, right? Now I don't even have to worry about the server infrastructure, right? Various connectivity options. You can connect to cloud, as I said, in a private manner, in a public manner, or in a hybrid manner, right? And you have a common management portal. Everything that you build on cloud, you don't interact with the physical servers themselves. There is a software layer that is built on top of it, what we call it a software-defined infrastructure. So you have software-defined servers, you have software-defined network, and software-defined storage. So you can actually access them using the single management console or a portal. Okay, I'll show that as well. Then finally, as I was saying, it's all software enabled. So you don't have to physically go and visit the data center. You can do it everything over the internet. Okay, let's look at how that all works. Okay, any questions so far? So here is how one of the cloud management console works, right? So what you're seeing here is the management console of Microsoft. Let's say you want to create a server, okay, or 100 servers. So I say, go create a resource. And I say, okay, I need to create servers. And I say, okay, create one for me. And I give some name. Let's say test servers Okay. And then I say, let's say Saturday 1. Okay. Then look at everywhere that I can actually launch my servers right now, right? All across the globe. Let's pick up somewhere in West Europe. This is in Amsterdam. Okay. Then let's say I need Windows 11, or I can have different operating systems. As you can know, every server needs an operating system. Let's pick up a Linux operating system. Have multiple sizes that are available, right? How you have different sizes when you visit, let's say, a clothing store, right? I can have multiple combinations of, I said, CPUs and RAM, remember? So all the combinations I have different, we call it the t-shirt sizes, right? So you can go from one vCPU to look at something like HB, which has 120 vCPUs or CPUs, okay, and 456 GB of RAM. And then it's also saying me, if you run this for a month, this is the total charges, right? It doesn't mean that you have to run it for a month. It means that you can run it for, let's say, 1 second. So then, you know that, it'll be a fraction of the cost for this, okay? So let's say just choose some, okay? Let's say I'll choose one, let's say password, create a user account and password. Obviously you need that to get into the servers. And then I just say, I can say next, then scaling. Here I can say, give me 100 servers. Okay, next, and then create. Okay, looks like something I didn't do here. Okay, some limits on my, let's just say, okay. So what I did while working for this is, okay, let's see how we can start those 1,000 servers together, right? So I have a game server that's running, and I want to build that. You'll see that number of servers coming in right now. And here is it. Here is one other way to launch the servers. As I said, it's all software defined. So you don't have to, let's say, kubectl. So this is using a container technology, what we call it as Kubernetes. As you can see here, I have around 10 servers running. Let's say kubectl get pull, and then get -l. Again, don't have to worry about it. So right now you have 12 servers running in my game server fleet. Let's say kubectl deploy. Okay, kubectl. Let's say scale my deployment. Okay, and then what is my name? This is nginx deployment. And then I say replicas is equal to 100. Okay, look at how fast from 12 servers, you see suddenly my number of server count increased. And then I can see how many servers are there. I already got 100 servers. Within few seconds, have 100 servers running, and you can see it here as well. Let's look at here, workloads, and my name of the deployment. And you can see 100 desired, 100 updated, 100 total, and 100 available. Okay, let's push the limits, and you can see it. Everything is already running, right? It took less than a minute to essentially have everything running. Let's go and scale to 1,000 servers. Okay, and let's do a line count. You can see 100 has already become 200. You can say 285, and if you go back here, and you'll see here. So I'm going to refresh my screen, and now it is 1,000. I'm desiring 1,000, Right now 100 is available, 900 is unavailable, meaning to say I'm about to start them. And you can see the servers are coming in, and it says container is created, right? And it's taking a few seconds to get everything up. When I refresh the screen, I should see more servers coming in right now. And then even in my command line interface, where I already have 1,000 initiated servers running, right? So how easy is it for me to start creating servers? Let's look at what happened to what we just started creating, right? Go to the resource, go to instances. I asked for 20, all my 20 servers are running, right? And this is running in where? In Amsterdam. I told create it in West Europe. So now you can do this programmatically. So you think about it. Now, as the users come in, as the players join the game, you can actually use the signal connected user, and then you can start servers in the background, right? No need for me to order a hardware, wait for 6 weeks or 8 weeks or months because of the global supply chain problems, chip shortage. Now, if you want to order, say 100 servers, it takes a year, at least a year to get the servers there, right? Now here, I'm able to create 1,000 servers in few seconds, right? That's the power of cloud that you're seeing, not just with gaming industry, but all across, businesses and industries. Okay. Any questions so far? All right. So by the way, let's say I'm done, right? I can just go back and say, scale down to 10. What happens as I reduce the number of servers? You'll see 10 is desired, 1,000 is available, and you'll start seeing those servers getting terminated. See, the number of servers are coming down. If I see, okay, it was 1,000, it's become 924, it's become 902. You get the idea, right? The servers are getting stopped as well. So I probably had this 1,000 servers running for a few seconds. So I only pay for those number of seconds that I ran the servers for. Yeah. See how fast it is scaling down. It's now 700, right? So as I was saying, that it's just one aspect of cloud, right? Already it's updated. It's already terminating. And so you'll get this number to 10 right away. Okay. So now what did we learn from so far, right? Why cloud for gaming? One is you can scale as you grow. As the number of players come in, you can increase the number of servers. You don't have to worry about buying and managing the infrastructure that is needed. Okay. And you can place the servers closer to your players, right? Now you can set players in Europe, in Africa, in Asia, in United States, where the players are together. Okay. And then you can now create servers faster. That means you can build my servers faster as well, because as a game developer, the cloud provides that infrastructure for me to test, build, and retest and get them to market sooner. Okay. And it also provides security tools, because you're not running on outdated hardware, you're not running on outdated software. Cloud is always updating. Because they manage large enterprises, they manage large banks, institutions, insurance companies, right? So there are standards and compliance that the cloud providers have to manage. There are some requirements that these industries have towards their customers. So the software is always updated. So you get the modern hardware, you get the latest of the software. In fact, you can test it on a parallel fleet of servers and then switch them, right? Because you're only paying for the number of hours or seconds that you're using. It's easy to create a 2x of the servers, test my new build, and then switch to the new gaming version. Yeah. And finally, it's cost optimized because I'm not owning anything. I'm only paying for what I use. And there are so many other ways to actually even optimize the cost within cloud as well. Something like spot instances, right? So even the cloud providers, right, they have spare capacity, and they will give capacity for 90% discount sometimes. So you as a game developer, you know, my games are played mostly over the weekends. I can use that capacity at a 90% discount. So now I'm not paying 1 cent. Now I'm paying 90% of 1 cent, right? To run those servers. There are so many different ways to optimize the cost. So in fact, you can design your game to benefit from these features that cloud offers. Okay. So finally, like getting back to this triangular talk, right? So we started with what is cloud gaming or gaming in general. How does an architecture of gaming looks like? What challenges the gaming industry faces? As a game developer, you saw how to scale the game, right? And then how cloud is helping in terms of mitigating some of those challenges, right? And purely from infrastructure point of view, right? Because that's a big deal. Because you want to scale for a large number of users distributed across the globe, and how cloud is helping here, right? Now, why stop there, right? What next? What's happening here? And here is an example of how my 1 million users or 1 million players would look like, right? There's a global load balancing. I have servers in multiple cloud regions. I have, and then wherever my user are, they would connect to a local region, let's say, and then a user, a player from Hong Kong will connect to a server fleet in Hong Kong. Yeah. So what's next? So imagine we talked about how you need a console, right? An Xbox or a Nintendo or a PlayStation, and then you need internet, and then you're using the game server fleet. What if I can move this console to the cloud as well? All I need is a controller or a mobile phone that I can essentially connect to this console, and then this console connects to the server and the game is streamed for you. Okay, now it is called as cloud game streaming, and this is picking up. You'll see more and more games available through this streaming platform. You no longer need the console at home, right? And these consoles are expensive, right? And these consoles have to be regularly updated, and they get outdated pretty soon. And it's one of the most sought holiday gifts, for example, right? So now what organizations are doing are moving these consoles to the cloud as well. So you don't need anything other than a controller or a mobile phone and start playing the same games that are played in big screens with high graphics, graphics intensive games such as Fortnite, for example, has a lot of graphics in it, right? This was impossible, a year or maybe 5 years ago. Now it is a reality, and because of the fast connectivity that you have over internet, to these cloud servers, and because they have gained the technology that can essentially stream that high graphics back to your a screen, a mobile screen or a large PC. Now you don't need like super expensive hardware even at your home. A simple mobile device or just a controller would do, right? And this is happening very fast. All major providers are working on it, and probably in one of the next sessions we'll go deeper into showing how this works. Okay, I think that's about it from my end. And I know we got extended by a few minutes, but happy to take any questions.
Maybe while the audience is thinking about it, I can get it started. For students who are interested in your field, what steps should?
No, absolutely. So this is, I think, one aspect that I wanted to the students to look at. Software engineering life cycle is if you're not interested in coding, if you're not interested in actually developing. Infrastructure design is one of the highly sought areas. And as I was talking about it, there's a lot of mathematics, it's lots of physics, right? It's about distance, it's about time, it's about speed. So if you're interested in these, if you're interested in looking at hardware side of things, looking at server side of things, there are so many ways you can get started today. Because of advent of cloud, all the cloud providers give you essentially a free toolkit to test this, right? You no longer need to own any of these to actually test it out. You can just go to a web console and look at cloud learning, and you essentially see a lot of resources there. I would also continue the path that the students are doing in terms of getting into science and mathematics, and because those play a fundamental role here. Anything about designing, about network storage, goes back to those fundamentals, right? Yeah, and there are a lot of learning materials online. I can also share with you, Matangi, which you can share with the students as well.
Great, thank you. Any questions from the audience? I'll probably wait for 10 seconds before I share my next question. I know we're coming up at 12 o'clock, or any questions from the audience? Okay, so maybe I will wrap up with another question. Oh, there is a question that came through chat from Ish Dubey. So you don't need a physical device to play games.
Correct. So now you need, but for example, let's say if you're using Xbox, there's something called as xCloud. What they are enabling is 2 ways of how you can play without a physical device anymore. One, you no longer need an Xbox at home. You can use the controller mobile device and connect directly to the xCloud, and then you can stream the game and you can play, right, over Bluetooth and to the screen. That's about it. Okay. The second is you stay at home, you connect to your Xbox remotely, and then Xbox connects to the cloud, right? So both options are available. Even Google is working on a platform called as Stadia. Amazon has a platform called as Luna. They all are working on cloud streaming. Yes. And in fact, Netflix also started game streaming. So you can actually play games in Netflix. You don't need a device.
Thank you. That is very interesting. Anything else from anyone? Please feel free to unmute yourself and ask the question, or put it on chat. So Uthappa, maybe while we wait for that, is there any advice that you'd like to share with the students here today on problem solving?
Yeah, absolutely. And I think we see these challenges day in and day out, right? Not just in specific to what we presented today, but when we think about the common theme that we talked about is the global scale, right? And what I would say that when you are trying to mitigate a particular problem, look at the bigger picture. Look at not just that how does it work, but how to make it work really well, right? As I'll go back to that same phrase that I was trying to say, that you design for failure. You think that some things will fail. There are so many steps, so many bottlenecks that you will see, and layers in while you're designing a solution. So think from that strategical point of view. It could be a long-term solution. It could be something that it takes longer for you to solve that. But look at a bigger picture. Look at how you can deliver things really well. And there is a parallel school of thought too. You start in stages. You don't have to always perfect it, right? When you have a problem in hand, you don't have to perfect it on day one. You start fast. It's okay to fail. And you continue to grow and build on top of it, right? Until you reach that level that you feel that it's working really well. I apply this every day. And as you can see here, things, are moving so fast. And I always look at one, let's take a step to solve your problem right now. Okay, you have a problem, let's solve it right now. But then let's look at the bigger picture and how to make sure that this doesn't happen again, right? That's something that I do, and I believe that could be applicable for anything, really.
For that, Uthappa, it seems you're advocating for continuous improvement, but starting soon and continue to improve on it. No, that's great advice. Thank you. We have a question from Annie. What are the ways we can develop interest in the middle school age kid to explore this side?
No, absolutely. Yeah. And gaming is something, you are already interested in. And like, hopefully when you pick up your controller or a mobile device to play, a game, then you look at like a broader set of things. And because of internet, you have so much of information today, right? Just go and look at YouTube, for example, like just, browse, how do you design something, right? And there are so many resources that you can start looking at and see where your interest areas are, right? Is it designing such large applications and web apps or mobile apps? Then some of the common themes that we covered today, and you will see those all the time. And so, yeah, one way to develop interest is that, experience it, pick up a game, look at it, right? And go and read on, how enterprises are doing this for large scale. And because most information now are available and easily accessible too. I would say, look at what your areas of interest are, and then look at, for example, gaming or media or entertainment or, or generally anything that deals with such large scale is of interest for you by looking at that particular industry first.
Thank you. There are a couple more questions, and we'll probably wrap up after that. One is from Varsha. What caused you to get an interest in gaming and innovation in gaming?
Okay. Yeah. First of all, you don't have to be a gamer. I'm not a gamer. When I started, you don't have to, right? But I was super excited by the scale of it, right? So anything this large scale, super interesting, right? Because think about it. If you're hosting a party at home, and if you're hosting a party for 100 people, it's so difficult, right? You have to plan so many things around it. If you're hosting a gaming party for 1 million users, it's a pretty big deal. So those things really excite me, and the technology behind it. And I think because of cloud, and it's so many ways you can tackle a problem, and infrastructure side of things is kind of taken care of. Now you can really look at the larger scheme of things, right? What are the tools that are available? How do you make it, more manageable, more secure? I think those aspects, and knowing the challenges that the industry is facing, I really got excited. And same thing with media and entertainment too. How do you build a next Disney Plus platform, right? How do you make sure that there's an online, game or sports event can scale up to, multi-million players? How do you design it? How do you make sure that things don't fail? And there's a common themes all across. But yeah, gaming is your thing, and definitely can look at this.
That's great. Thank you for that. There is a question about which cloud provider is more promising in the gaming industry. I don't know if there is a conflict of interest there. Some of the options are GCP, AWS, and Azure. Would you like to comment?
Yeah, no, great question. So all the three cloud providers are leading cloud providers, right? And they are the major players in gaming industry as well. Each of them is, because the gaming industry is growing so fast, and they are developing tools and techniques so that all the things that I showed you are just available with set of APIs. You don't have to worry about anything like this, scaling out, scaling down. The APIs take care of them. So all the three are, making and they're contributing back to the open source community as well, where you as a developer can actually pick up those tools and start using it without actually paying for licensing. So I would say all the three are doing really well. One, Google is a great strength in its network. AWS is a pioneer in cloud computing, and Azure benefits from having the Xbox infrastructure at home, as well as the large number of data centers that it's spread across compared to the other two. So all three are actually, I would say you just have to pick one and start working on it, or you can pick all the three. Maybe in one region, Azure is great. In one area, in AWS is great, right? So you pick up, the differences, and then you pick up one and then start using it. And then you'll see with the container technology that I was showing, they work all across. So, what is your preference? You want to keep closer to the user. So look at, a provider who are closer in those cities. Because the containers that I was creating, they're all open source and they work in all the three cloud providers.
Okay, thank you for that. And the last question, and we'll wrap up with this. Can you elaborate on the career path for kids who want to get into gaming industry? Sure.
So obviously engineering, I would say, would be a starting point if you're looking at the server design, the aspects of infrastructure design that I was showing, because it all deals with, mathematics and science and as I was saying, the aspects of what goes within a server and how do you work on it. And now it's all software defined. So you are forced to kind of adopt a software engineering based courses and curriculum. But let's say you're not looking at designing the infrastructure, but the game itself, right? You want to build the game itself, right? There are pretty cool courses that allow you to start developing a game. There are few platforms that are very popular where you create those games. I could share some of those links after this, and then there are courses available from a lot of providers online where you can start actually creating those games using those platforms. In another area that you could also be interested in virtual game artifact artist, where you actually draw and create those large structures. It could be cities, it could be forests, it could be these cars that goes and that you see in the games, right? The process called as rendering. So an artist actually draws using a digital pen, and then he converts that two-dimensional model into a three-dimensional model, and then he inserts them in the gaming, let's say, call it as a gaming world, right? That process is also very interesting. If that is something that you have and you have interest within arts, that is an area that you can look at too. So I would say broadly, these are the three areas that I would say to look at if you are interested in the gaming industry. The game hosting or infrastructure, the game development, and game design, using your artistic capabilities.
Thank you. That was very, very comprehensive and very helpful, Uthappa. And throughout the presentation, I was super engaged, and I'm sure the audience was too. Everyone is on, so and everyone is fully attentive and chiming in with questions. So thank you so much. And just for the audience's benefit, right? It's not just this hour and a half that Uthappa has spent with us today, but also all of the time that went into the preparation for this talk. So I want to take the opportunity to thank him again on behalf of the entire audience and Agora Math Circle for taking the time to do this today. Before I go into the wrap-up session, just want to confirm, Sanvi, were you able to get a screenshot of what you were looking for? I think Uthappa went to slide 22.
Yes, thank you.
Oh, wonderful. Awesome. This was, again, as I mentioned, Uthappa, very, very engaging presentation, and the demo and the Excel and everything. I was super engaged, and I'm sure as was the audience. I personally learned a lot, and I hope all of you did too. So now each of you, and we're seeing some applause, on Zoom. Hopefully, Uthappa, you're seeing that on the screen as well. And each of you is, playing video game, and when you have that seamless experience, now you have some idea of what goes into making that happen, right? And all of the how-to questions that Uthappa was posing, bringing it back to the theme of triangular talks, all of the how-to questions that Uthappa was posing, they're all problem statements. And then there's innovation leading to solution. And in this case, cloud happened to be the innovation leading to a cost-effective, scalable solution, and many other features that Uthappa talked about, right? And we also saw how some of the math concepts are used in the day-to-day, including estimating the number of servers, cost management, load distribution, things like that. Whether it's simple concepts like multiplication and addition, or a little bit more advanced like probability, those are all concepts that you're learning today, and hopefully it reinforces your interest in those concepts. Again, I want to take the opportunity to thank you, Uthappa, and the audience as well for your attention. Thank you again. And with that, we'll wrap up. Have a nice weekend, everyone. Bye.
Thank you. Bye. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!